Hello and welcome back. Now, I think you remember this one from the last video, and this one is our initial design. Now, what I want to do is I want to change this a little bit. It looks something similar to this at the end of it, but I want to do some adjustments before moving forward because you're going to need to test the components and see if they were proper and if we connected them properly. Basically, building it part by part. So I will do, and also understood there's a flaw in this design, is that yes, we can kind of control the voltage divide between them with a potentiometer. However, there will be a big problem, and that will be with the current, because the current will be quite very small. So a way to like maintain a high current while also having the voltage would be to use a transformer, and basically transforming these 240 volts to a simple 24 volts. And for that I did buy this, but I don't recommend you to buy it. It's this little Chinese potentiometer that exchanges the 220 volts to 24 volts. It's not really high quality or anything like that. I mean, it looks quite good, but it's not. It's got a limit of 2 watts, and yeah, that's about it. You see, it even says here, and 2 watts as you inspect it's very small, and this was already 10 pounds. It was actually 9 pounds, so it's not really that worth it. There are other ones that have like higher power, but it was around 20 pounds, and I could have bought like a laptop charger as well, and that one was around 20 pounds as well. So I thought might as well just buy this 9 pound one, do some experiments with it, because we are not going to use it in the end. In the end, I'm still going to buy a proper DC power generator, but so we have it with us and we can do some experiments with it, see, do some testing now. So let's use this blank piece of paper and redraw it. So what we'll do is we'll draw the source in here. There you go. Actually I've like moved it. There you go, the 220 volts going up here. And now what we'll do is we'll draw the transformer. So I think the symbol is something along the lines of this, just squiggly lines connected together here, and then another squiggly lines here, representation of the iron core, and there we go. So this one will be the transformer that does this one to 24 volts, and remember it's still AC, so it's still alternating, so we'll still need to do the diodes, and basically we'll have it like this. So one of them will go this way, one of them will go this way, one of them will go this way, and another one of them will go this way, and they'll be connected at this point here, and this one will be connected at this point here. Then again, it's the same diagram as the one last time. Then we connect it through here, so there you go. Then this one will jump over because to be the negative side, and then this one will go here. Then it will be the capacitor. There you go, very nice. Then we'll just put a resistor in here, no potentiometer at the moment. There you go. And what we'll do is we'll test the following points. So let me grab another color. There you go. And we are going to, all right, I'm back. Sorry, let me put the flash back on. There you go. So what we're going to do next is, of course, we're going to test it. So first we'll test to see if the actual transformer works. So we'll test at this point here and this point here. Then we'll test if the diodes work and if they are put properly. So we'll be at this point here, at this point here, and then at the end we'll test this point here, this point here. Obviously we'll still have a resistor between these points, because you don't really want to have nothing in there, because then you'll make a short circuit. Unless not DC with DC, but I don't want to risk it. I don't want to make a short circuit, because who knows, maybe I can make it with AC as well. And I'll go quickly again over the current flow because it's really important. Basically, when the voltage is positive, current goes in this direction. When voltage is negative, current goes in the opposite direction. So let's say this one is the positive, this one is the negative. Then let me get another color here. I don't know, orange, I guess. Then the positive current will go this way, will go in this direction here, then it will go through here. So this one will, so the current will flow through here. And the negative one, because it goes in the opposite direction, because this will be the flow in the normal direction, the positive direction, the minus voltage will go in the opposite direction. So I'll use this blue one. It goes through here, it goes up, it can't go this way, it goes this way instead, and there you go, and both of them meet here. And that's why the end graph will be something like this, because both currents have the same direction in the end. Okay, so that's why there's no negative voltage, because both currents have the same direction. I hope I made this clear. And of course this one is the negative, because after the flow it will just go around and both of them will come back, and they will go back through the same direction, either through here or through there, depending if the voltage is positive or negative. But yeah, we don't, what we care is that both of them come in the same come in the same direction, and both of them come out in the same direction as well at this point here. We don't really care what happens inside of here. And yeah, so now that we understand what we are going to do, I'm going to pause and we are going to actually work on it and build it a little bit. Alright, welcome. So I've set up the digital multimeter. Basically I give him the needle heads that I showed in the last video. So first thing that I want to do is I'm not sure if this is the 10K resistor. What you can do, you can actually read it off, like reading the color bands, and determine that way if it is, or it's an easier way that I usually like to do it, which is simply, if you give me a second, like you can measure resistance, make sure that it's no current going through it, so that there you go, because if there's current going through the circuit and you measure the resistance, then you'll break the entire thing. So, oh, is it higher than that? Yeah, there you go. Let's see, so it's on the 200K. That means this is actually a 100K resistor. Yeah, that's fine, it's not that bad. Alright, again, if it shows you a 1, that means it's actually higher than that, so that's why I moved it to the next one. Alright, now let's see, the next step will be to test the transformer. So from the diagram that we drew, here the first one, we are going to measure these 2 points here, and we are going to put the resistor in there to make sure we don't do a short or anything like that. So the way this works is that I'll put the transformer in here. These two are supposed to be connected to the plug, then these two are supposed to not be connected to the plug, to be connected to the resistor. So what we'll do is I'll put one of them in here and one of them in here. There you go. Oops, no, not yet. Give me 2 seconds, please. We'll put one of them here, and then the other one in here. Again, it's a bit hard because this is not the highest quality. What else we need? Well, we need to connect them together, so we'll just put the resistor between them. So one here and one here. Actually, I'll put it in here so I have enough space for the needle heads to put in between. Okay, there you go. Now what we'll do is, again, it's not plugged in, we need to connect these ones. So one of them will go here, the live wire. There you go, it's in. the neutral wire will go here. There you go. Oh wait, that's the earth, never mind. I almost did a blunder there. There you go, put that one here, far away from the others. And now the neutral will go here. Alright. Again, I'm not wearing gloves or anything. I'll put them now on. Because, again, I am just connecting them and nothing is plugged in, nothing is going. There's no current, nothing. Alright. Man, I'm so scared of this part because I don't want to turn off and blow a fuse again from the house. So I'll just move everything a little bit that way. I'll just take this and put it in here. Oops. There you go. And now, okay, and now I'll have to, sorry about that, I'll have to plug it in. And hopefully nothing bad will happen. So there you go. Okay, nothing looks burning, nothing is burning, that's good. All right, everything looks connected properly, which is good. Nothing is blowing again, which is good. All right, now when you measure anything, you tend to, except for the resistance, because the resistance is kind of affected, you tend to set it to the highest one. So let's set it to 600 volts, and it's the alternating one. And I'm going to put the needles in here. So sorry, let me, there you go, leave it at the 200 normal, and it should be fluctuating between, sorry about that, between 200 and between 24 and minus 24. This is strange actually. I mean, it is a step down, but it doesn't really alternate. It is stuck at 28. How particular. Okay, let's set to the direct current, and then on direct current maybe to show the minus. So let's try it that way. Now on direct voltage doesn't show anything actually. It shows the positive and the negative at 20. How strange. So transformer is not really the best since it's at 28. Alright, I will, maybe the problem is this voltmeter. I got another one. I'll pause the video here and I'll plug everything, and then I'll see you back with the other one, see if I can see any changes in that one. Okay, this is the other one that I own. I'll put back on my gloves and we are going to see how it goes. So just give me a second. There you go. Nothing blowing up, nothing burning, which is good. Volts alternating. It shows the same thing. Let's see if I switch it to direct. Now the DC doesn't show anything, which makes sense. I guess it is alternating between 28, about 28 volts. Alright, I guess it's 28 because in the UK it's 240, yeah, and this one says for 220, and I guess the surplus will make a bit higher by 4 volts instead of being 24 to change 28. Alright, so I'll pause again the video here and I'll unplug everything because you shouldn't work when everything is plugged, and I'll be back. Right, I'm back. So these are the diodes, and I guess we are going to use this ones here, and I made sure I checked. So as you see in the diagram, they have this line here to point the direction that the current is allowed to go out, and real life diodes have the same thing. In case you don't know how to read them, let me just, there you go, you can see they have a gray band here, and this gray little band. Hello, it's me Alex again, and yeah, this will be a self-insert. Basically, uh, because of my poor camera quality of my phone or lack of focus, this is what I was trying to explain. So when you're reading a diagram, this end right here, and you can see clearly, it's represented by this gray line here. Actually, let me change it to 10. There you go. Basically, this one here, it's represented by this line here. So if you want the current to go in this direction, basically you put this line here facing that direction. And if you want to do it in the opposite way, you'll just put it in the opposite direction, just flip it around, and it will be the other way around. Just want to clarify that because, yeah, I don't want you to make the mistake of connecting that wrong, because then the circuit simply won't work, or you burn the diode, because they still have a limit of how much current they can hold back. Alright, this was just a quick update on it, just to show you how it actually looks and how you should connect them. It's representing the direction here. Basically, this is how you're supposed to connect them. So let me just hold it properly. There you go. See, you're supposed to connect them like this to represent it. Alright. Again, everything is unplugged. Just double checking now. Yeah, it's unplugged. So let's get started. And we are going to connect it from this point here. So then let's see, I'll connect one end here and one here. The great thing about these little things is that you can do temporary circuits and change the components really quickly. The annoying thing is that sometimes it's just hard to push them in to actually stick in. Anyway, let's pick a new one. There you go. It's the exact same type. Is the 1N4003, and this one, as we see from the diagram, is supposed to go in and connect at this junction here. So what we are going to do, we are just going to connect it again. Yeah, it's in. All right, so I don't know if you can see, but on line 16 it will be this line here. This will be, actually I can write it down and you can see it. So line 16 be this one here, and this one here is line 19. There you go. So this one will be line 19, and then this one here will be line 17. There you go. So we don't get the confusion. This is line 19 because this part here, which is this one here, is connected to this diode, the input of it, which is here, and also the output of this one, which is here. So we have done 2 of them. Now we need to do the other 2 ones on the negative point. Again, next one, which is this one here, we'll need to connect it from the neutral to point 16, facing that way. So just making sure the line is in the correct direction. Otherwise, it will burn because it can't keep up back the current or something like that, or maybe it just won't work at all. So now both of them are in. This one is in. This one is in, this one is in. Let's point the correct direction. So it's line 12. So this one will be line 12. There you go. So we got the 12 to 16. Now we need a 17 to 12, and it's done. So pick another diode. Let's see. So line 17, which would be this one here I need to be careful not to touch them. I need to be careful like the legs don't touch each other. Alright, so we got this one going in, this one going out. This from this wire this one is going in, this one is going out. So that's perfect. Now let's put some safety, and by safety I mean the resistor. And we will put the resistor at points 16 and 12. So 16 and 12. Alright, this will be too crowded, so I'm going to cut some wires. And no, actually I don't need to cut wires, we have the temporary wires. I'll have, let's call the red one the positive and the brown one the negative. So the positive, which will be a point 16, as you see from the drawing, line 16. So there you go, line 16. And we are just going to put it on line 7. And then again from the drawing, we'll have line 12. And then we're going to put it on, let's see what lines are here. Line 12. And then I just put on line 2. There you go. And now I'll just put it like this. The resistor in between them. There you go. Just let me move this up a little bit. Alright. And I will have to plug it in now. So is this a recording? Yeah, it's a recording. You guys can see it. I'll put on my gloves and I'll plug it in. Just give me a second. Again, let's hope that nothing burns or nothing blows up. If something burns or blows up, I'll just have to quickly get it out of the socket. Alright. But it should be fine. Nothing should burn. The resistance is quite big at 100k. And yeah, there you go. Let's see, smoke. No smoke coming out of it. That's either a good sign. Alright, now this voltage should be DC. So let's grab this one again, move it to 500 for now, and the positive pin will be at point 16. Oh sorry, not, it'll be at point 7 red wire. Then this one will be at point 2, and there we go. Let's see. So wait a second. Yeah, 12.6 volt is going through it. Man, this is so strange. So from the 28 AC it went all the way down to 12.6. Okay, I can still work with this, but it's a lot smaller than I wished it was. And I wonder why it's that. Maybe it's because of the resistance. It might be that. I'm afraid to use a smaller one, but I guess we can try that. So I'll pause here and I'll use a smaller resistance. Oh wait, I can't pause with the gloves on. There you go. Okay, now I'll just switch this one off for the 10k resistor, which will be this one here. And yeah, we'll see if it changes anything, but I doubt it. If not, we're just going to work with 12 volts, I guess. It might also be the diode actually, but again, I'm not 100% sure on that. Can we actually measure the resistance between them? Yeah, the circuit it's not having any current going through it, so I guess we could do that. Let's see, so let's start with 2000. Do you have any resistance between you? Oh yes, it does quite have some resistance. Alright, What if I turn it around? Maybe that was the problem. Yeah, it does have about 10k resistance actually. Alright, so okay, I plugged it back in. This side's got the 10k resistor. Now let's see if there's a difference in it. So let's put it on 200. One end here, and then the other end will go here. And no, it's still about 12.4. Oh, sorry, they're gonna get it. So I guess we'll work with this then. Oh, it doesn't look like it's fluctuating, but let's put the capacitor to see if there will be any change in there. I'll pause the video here and I'll put the capacitor.
Hello, it's me Alex again. Now, I tried to do a calculation for it, but I didn't really figure out why I did that, why I get the 12 volts. However, I am pretty sure the cause is one of these two. It's either because of the there it works. Okay. It's either because of the diodes, and it's something with the diodes, like the resistance inside of them, even though I didn't really understand it and I didn't really see anything to grab my attention. Because how do I say this? Because I have the here. I don't. I'm not that. I'm not an expert in diodes. There's the data sheet for it, and it gives you the information about it. And the one that we are using, the 1N4003, I think as it's got the peak voltage RM of 200, basically does just the peak and 240, which is fine. It's safe. We can use even the smallest one if we wish, but we don't need to. And that it's got an average rectifier volt of 1 amp, and non-rectifier peak surge is 30 for one cycle. So I'm not really sure what all of this data mean. It doesn't say anything about the resistances out of it or anything like that. It mentions temperature and stuff like that, but again, I'm not 100% sure. So it might just be the diodes the problem. But another strange thing that I guess the problem is, it's also the transformer itself, because again, it's a cheap transformer. It's not something of high quality. It's not something very specifically made for this. And from the beginning, you saw there was an offset of about 4 volts because we're getting 28 volts. And the fact that now we are getting with only one resistor 12 volts, it makes it a lot stranger. So yeah, and again, like the first time we got 12 volts. Oh, let me do another color actually. Red. Yeah, just saying, like the first time we got 12 volts. Oh no, sorry, not 12 volts. Sorry, 28 volts. In the first one we tested, then we got 12 volts. Now the second point we tested, and you'll see just in a second when I put the capacitor, we'll get about 38 volts. So what is this teaching us really? Is that the circuit that we made is not very, how do you call it, reliable. Is not, it doesn't really help a lot, because the way I expected it to go, it was the following. I was expecting to go something like this, get the 24 from the transformer when it is the first time, and not 28. Then when we put the diodes, maybe get a bit higher below, let's say like 25 or like 23, something like that. And then at the end, I was expecting to get the perfect again, 24. But how this circuit is built and it's going, it's very strange, because we are going from 28, which is above the what the transformer should give us, down a lot to 12 volts, which is very low. It's half of what the transformer should give us, and then back very above to 38, reducing the next step. So yeah, again, that's why it's good to build circuits and test them out, because in theory it should be something like this, just a simple straightforward answer, 24 to like 25, maybe 23 fluctuation, and then back to 24. but instead we get this. We get 28 to 12 to 38. So yeah, so that's why you should always build a circuit. Anyway, I'll stop this here, and I'll see you back in a second because there will be another problem with the capacitor.
Okay, so they are the capacitors. We'll go with a small one. We'll go with 100, I guess. Let's see how much this one is. This one, it's I don't think you can see it, and I can see it in the camera. Let's see. This one is 70, okay. And then, is it this one the 100? No, this one is 200, okay. Oh, this one is the 100, there you go. Alright, so we got the 100. Now, let's see. So, we'll have to connect it through here. Hopefully it don't blow up or anything like that. If you are wondering why I'm scared of things blowing up, it did happen to me a couple of times, and I don't know, it's not really that scary, nothing bad really happened, it's just it panicked me a little bit. Anyway, I'll put the gloves on now, I'll plug it back in, and we'll see if there's any change in it. If there isn't a change, then I guess I would just leave it at the capacitor. Oh no, there you go. Don't want it to fall. No, don't fall. There you go. Just, oh god. Just stay put. Oh well. I don't know why it was sitting a second ago and now it doesn't want to anymore. There you go, now it's it. Alright. Now, let's go through it. No smoke, nothing blowing yet. One end going here. And now the other end. No. Out. I can smell something burning. Alright. We are not putting capacitor through there. Oh yes, but of course. That's why it was burning. I put it the wrong way around.
Hello again, and sorry for the poor drawing, but I just want to explain what was happening in the circuit at this moment. So basically, we were getting in a voltage of either a fluctuating, we're getting in a DC voltage. So it was just give me a second, a DC. And basically how we connected the capacitor the first time, the negative value was at the top here and the positive value was here. And we got the resistance. It was either on this side or on this side, but the resistance doesn't really matter because they are connected in parallel. And what was happening, and I'll show you the red one, was the following. So it's an explanation why it was burning, why it burned, and why it was dangerous. So basically, the DC power was going, this way, and then it had the choice to make. It's either going through here, which has got like a 2 ohm resistance, or it's going through here, which has got a 10k resistance. I hope you understand my writing here. I'm doing it with the mouse, that's why it's ugly. And then obviously the current was like, well, why should we go to the 10k when we can simply go to the 2k? So yeah, so the current basically was going this way, and that created the short circuit. And basically there was so much current going through here, and it was so fast, and the resistance was so small, the capacitor was simply burning up. It couldn't keep up, and there would be no current, no voltage going through here. I mean, it'd be, because this one basically it was a short circuit, so nothing will go through here. So the correct way to actually do this would have been to Oh, I need to delete it. Okay. We've been to. Let me put back the thing. Okay. There you go. Now it's better. We have been to move them around. So instead of this being a plus, it should be the top side the plus and the bottom side the minus of the capacitor. And again, there are many ways to figure out how to do it. I think you saw in the video as well. Basically, you can determine by the legs, the size of the legs, or even more importantly, a capacitor is got a little black band of a minus. Actually, I'll Google it quickly to show you. So just give me a second here. Google capacitor, just the image of it. Alright, there you go. So this one's look exactly like ours. So that's how way to realize. Basically, the negative side will be this one with the shorter leg, and it will have this gray band here with a minus on it, and then the longer leg will be the positive one. In case you're wondering how you determine the plus and minus side of the capacitor. And not all of them have this, like very small capacitors, they don't even matter which way they are, so you can put it anywhere you want. But yeah, now that this is the direction, basically what will happen will be the following. So again, let me get the red one. Basically the current will go this way, we'll ignore this side because it can't go through here. And then there you go. It will go something along with these lines. And meanwhile, going through here, some of the current, and I'll color it with like green, where a little bit of it will leak through here. There you go, until it's fulfilling itself until it reaches maximum charge. So if you imagine this as a little battery, basically it's just charging up with passing time. There you go. And yeah, the more the circuit stays on, the longer it will charge up. And it's not really the circuit staying on, but it's more of the fluctuation. So because without this capacitor, and I'll do the drawing again because I don't mind, then the circuit will look something like this. But because of the capacitor, then the new one will look something like this. To go slowly up and down, it will keep it above a certain line. There you go. And this is not a short circuit because the current can go in this direction, can go up and down, but it can't go in this direction. It can't go this way, pretty much. So yeah. And again, remember, you should always connect capacitors in parallel, especially for DC. Don't connect them in series because then they will overcharge and blow up or burn like I did with mine. So yeah, and basically when the current is slowing down, it reaches almost to zero, then the current inside the capacitor will be the one that goes forward and completes the loop instead, keeping it going properly. So a good way to actually determine how you should connect it is to follow the DC, because this has got a plus and a minus in here, and the capacitor again it will be a plus and a minus in here because the capacitor will be a temporary battery, to be a temporary DC power, a very small one for very short periods of times, but it will have the same function to allow current going through here. And again, the capacitor current will never overcome the actual current of the DC, so don't worry, it won't go in this direction because it can't. Alright, hopefully I made it clear why it burned the first time and why this time when I connect them properly it doesn't burn. So, and also for you to look out on the way that you connect the capacitor, because if you connect it the wrong way, then yeah, it will burn. Alright, I think this is one of the last updates that I'll do about this circuit, about the testing phase, and I'll see you in a bit.
Another 100, and I'll put it in this way instead. And I'll also move the resistor to be ahead of it. There you go. And now I'll put this way, and hopefully this time it won't burn. Now, alright, guys, the second you smell something burning, you know it's really bad, so just shut everything. Therefore, oh no, not again. I need to set up this again. Oh, there you go. Just do this. Yep, that works. Alright, I'll put back on my gloves. Everything is connected. Yep. Alright. Let me put them back on again. So this one will be here. Then this one will be here on point number 2. I'll just, there you go. Alright, now I'll plug it in. Okay, nothing is burning this time, so that's good. Alright, this is really interesting actually, because you can see here, now instead of having that strange 12 volts constant, instead now we got the 38 volts constant. You know, this tells me something very important. I shouldn't buy Chinese transformers. Right, so at least this one is not burning. I can't smell anything burning, which is a very good first step. Now, 38 volts shouldn't be that bad. I should still be able to use an op amplifier on it, and I'll show you in a second why I want to use an op amplifier. So now that we tested the design and that we discovered a lot through it, for example, going from the 28 volts to the 12 volts after the diodes, then right back to 38 volts. So it doesn't really stay constant. That's one of the things that we learned. And we also learned something important, which is that testing step by step can save you. Imagine if I just built the entire circuit and then the capacitor was the other way on ground. First of all, I didn't know from what part was burning, and second of all, I would have put the entire system in danger if I wouldn't be able to be prepared to disconnect it and anything like that. Alright, so let's make a note on our paper. So there you go. Just to make sure, we are going to note here that, let's see, the negative leg is in there and the positive one is in there. So the negative leg will be here, then the positive one will be here. A bit harder to annotate with gloves on, but yeah. Alright, so we got the circuit. Now what we have to do is one last step, which is here, and that will be to connect an op amplifier in here to be actually able to control the voltage, because I doubt that I'll want to use a 28.5 volts all the time. It is kind of constant. It does represent the graph. It does represent what we tried to do the first time. So now I'll just unplug it. Should turn to 0. There you go. See, the capacitor is discharging. That's why the numbers are going down slowly. It was charged before and I think it was holding in, yeah, it does hold in 35 volts. It's not really holding in 35 volts, it's rather out in the current. But yeah, after it disconnected, it discharged slowly, and because it discharged I know this is one it's safe. I'm not sure if the other one discharged. I was too panicked to notice, but if it didn't, then yeah. But anyway, don't worry about that one. I've already disposed of it because if it burned, if I smell smoke coming from it, if I smelled it burning, then I know for sure it wouldn't work anymore in the future. It's already broken. And that's why you should have more pieces, more spare spaces. Alright, I'll pause in here, I'll clean up a little bit the table, then we'll go back to the theory. Okay, welcome back. Now we're going to go through the next step, which is this one here. This is an op amplifier. We've done exercises with it before. It's this little thing here, and it's got on the top here a notch, meaning that the pin rotation will be like 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, sorry, 8. This is not a 9 pin. And I've done the diagram of how it looks on the inside because you have a better one on the computer probably, but because I can't really use my phone since I record with my phone and I don't have my laptop on here, I just drew it on the piece of paper so that I know what I need to do. So we got the inverting, which is pin number 2, non-inverting pin number 3. These are the two ones that we care about. We also care about the power, which is the voltage plus, which is pin 7, and the power, the negative voltage, which is pin 4. We won't really use this one because we won't have a negative voltage, so we'll use pin 7, and then the output will be pin 6 of this one here. So pin 1, 5 and 8, they are useless. They don't do anything really for us. It's quite a big chip for such a small number of pins, but anyway, I'm not sure what the offset null means. I know this on NC not connected means this one literally does nothing for the circuit. So let's get going then with a new drawing diagram. Now let's call what we did before, which is on the other side, which is here. Let's call all of this just R. Alright, welcome back. And yeah, I paused the video again because first of all my phone needs an update, so it stopped, and then second of all I needed the internet again for the diagram. This one is the non-inverting amplifier, and basically what we're going to do, we're going to feed in 1.5 volts, which will be from here because that's the minimum battery can have, and also we'll have an R and R reference, and the formula for it is AV is equal to 1 plus RF over R2. Another very important thing from the last diagram, which was this one here, we also need to feed in power, the voltage plus. That basically make the voltage higher. So that one will simply be, just let me do this, there you go. And then I will, just give me a second here. We'll say it's the rectifier R. There you go, and that will be the positive side of it, and then the negative side of it will be connected here, which will be also a representation of the ground, and then this pin here will also be connected there, and there you go, it should work then. Because this one is still seen as DC, but it's a lot higher. It's got the potential of 38 volts, but we won't need that much, and it's got the voltage out in here. Now what we want to do is basically we want to know what the maximum is, and we would like to have a maximum of 35 volts V out. So pretty much what that would be, it's we would want a gain of, just give me a second, oh there it is. See, so if you want 35 volts, then we have to divide it by 1.5, a gain of 23.3. So let me check on the potentiometers, see what types we have. Just a second. There you go. Do we have something within that range? So 23.3. Let's call R2 1K because this one will be easier. So sorry, R. So that will be 1K ohms. There you go. So then RF will be need, so let's rewrite it here. So we'll need 23.3 We also will be equal with 1 plus RF over 1k ohms. Then that one will be 22.3 equal with RF divided by 1k ohms. So if we multiply it, then we will need 22.3k equal with RF. So do we have something within that range? And the answer is not really, no. Alright, we have a 20k here. We have a 200, no, that's too high. That's too high, that's too small. Man, we don't have something between them, do we? No. Alright, let's get a bit creative. We'll use two potentiometers, I guess. We will use the 20k, no, yeah. We'll use the 20k and the 2k one. So for RF here, we are going to use two potentiometers. So it's one of, so let's delete this line here. One of them, and then the other one, and then we'll connect both of them here. RF2, RF1. This one will be the 20k, and this one will be the 2k. Basically refine it. I don't think it's a 3k in there. No, it's not. Alright, that's fine. Or no, 2k it's enough. We'll have a bit less of than 35 volts. We won't have a perfect value, but that's fine. Alright, so now that we have the diagram here, we just need to build it. So let's get to it. So we have it here. We have the pins here, so that'll be easy. So I'll just put it down here and I will get started, I guess. So just let me get back the other things, such as this one here. Oh, again, just there you go. This is just a bit of the annoying part, getting this one. Alright, so I'll just need, sorry about that, that was the battery. So I'll just put this on, hold it in place. Okay, we don't need the resistor here anymore. So let's get started. First, let's start with V in. It should be pretty easy. Basically connecting the red wire to the positive pin, that's pin number 3, so it will be connected here. There you go. So that was the first one. Then we need to connect it, this one, to the negative, which let's just put it in here. Perfect. There you go. So this one is connected there, and we are going to need another negative wire. So there you go, we have them here. I get this black one out. Basically I'll connect this one, the negative, here. Alright, perfect. So we have the ground, we have connected this one, the first one. Now what we'll need a another wire. Actually, we don't really need the wire. We need to connect the 1k to the ground there from the non-inverting side. So now let's go to the next one. So from the diagram, we need to connect it from the inverting, which is pin number 2, towards the ground. So pin number 2, which is this one here, and then the ground is this one here. There you go. I can also connect it here, I think, but I just want to make sure, just to be safe. Anyway, now, yeah, actually, I'll just, there you go, pin number 13. There you go. Now the next one, we need some more wires for this one. Actually, we need to create the junction, which will be here. There you go. And then let's put it in here. Alright, now we are going to need the potentiometers. So the first one will be the 20K, which is 3, there you go, is this one here. And the way we connect it, it's like this. Hopefully it went in properly. Just, there you go, it's in properly now. So one leg is connected to the top one. I need to connect another wire to the middle one. There you go. So then this one is connected to the middle one, and then we'll connect it through here. And we'll just repeat the same thing for the 2K one, which will be this one here. Right. Now we'll just put it the exact same way. There we go. And again, we'll just connect this one to the output. So the middle one will go right to the output, and the output is pin number 6. So this one will be 5, this one will be 6. So there you go, this will be the output. Then we are going to connect the 10K in here to the output, and here on line 20 again we are going to get another wire, and this one will just connect it from line 20 to the ground. Now actually let me move it one more so I can have enough space to put the multimeter for the measurement. There you go. So this one will go from here to here. Perfect. Now the next step will be to actually plug in this one here, the positive. So let me get a red one for it to make sure. There you go. I'll try to, there you go, managed to take it. So then the red one will go here, and from there we'll go to the power, which is pin number 7, which is this one above number 6. So I think you saw a little bit of my head there. Just need to look closely to it. Come on, there you go. It's a mess, but don't worry, it will look neater when we actually build it. All right. Now I'll also put the voltmeter, because there's no reason for me not connecting it right now. There you go. And then to be at the positive and negative, so to be one here, and then the other one here at the negative. All right, we'll put it on 200, shouldn't be more than that. Okay, now we'll put the battery in here before plugging it in the socket, because the battery is, there you go, nothing going through it, which is fine for now. And then the next step will be to prepare the screw drive, which is this little one here that I have personally have it and found it. And basically what we'll do with it is we can move it from one side to the other on this, see, there you go. So I want to make sure you can see everything. So there you go, you can see, you can clearly see that one now. We can see this, we have that there, the first section. That's why you also need multiple of these, because imagine how complicated it would be without it. Now I'll put on my gloves and we'll power it. Actually, just to make sure, I'll connect one more wire, one more ground, and that will be from pin number 4 to the ground, just to make sure nothing bad goes. So there you go, pin number 4, which is this one here, to the ground. Alright, now that everything is ready, I'll put on my gloves. Alright, and then I'll just have to plug it in. and if you are lucky, then everything should go fine. If you are unlucky, you will smell something burning. Alright, there you go. See, already 36 volts. We are already getting a gain, which is fine. We are already getting something to there. Okay, nothing smells like burning yet, which is fine. So the op-amp can take it. Alright, let's make it a bit smaller. So, because sometimes op-amps can take high voltages. There you go. So I moved the 20K. Now we are having an output of 14.4 volts and it's constant. So it's a success. So that's how we can make at home our own DC. It's not perfect, it's not the best way, but it is a good way indeed. There you go. So if I make it to the highest value, let's see what we'll get. We should get like 1.5, something similar. Yeah, we get 0.5, that will be 5 volts. And let's see how small can we actually make it. There you go. So they are the smallest values, and the smallest we can go is for, it appears to be 3 volts, which is fine. And let's see what's the highest we can go for. So, oops, I dropped it. So then the highest we can go for is 36. Yeah, about 36, about 37 volts. So that will be the highest. Which makes me think, do I really need a 2K then? Because, and again, because if I use only the 20K, and if I put this on the smallest value, just give me a second to be hard with the gloves. Nah, the 2K doesn't really make a difference here. The one that makes the difference here, it seems to be the 20K actually. Yeah, and even this one, it's a bit slow. Yeah, okay, when it goes past the half point, it doesn't really go that much higher. But yeah, I guess I can just use the 20K instead, and that should be fine. So we'll go for that. We won't use the 2K, use the 20K, as you can see here, because it reaches the same maximum, about 34. It doesn't make that much of a difference. And yeah, we can go all the way down to 3 volts or even smaller without this one here. If I move it the other way around, yeah, it increases here. I guess we can use this one to fine-tune it, because if you get the 20K all the way to 0 and then we just move only the 20K, then it will go up to 14 volts. So we can have a play with this. We can play more with it once I actually finish it and put it on one of this. And I'll actually show you how to solder a circuit in one of these, but we still have a couple of steps to do. We still have to do the actual complete diagram, you know, the one that looks a lot nicer. But yeah, I'm very happy it actually works. It's quite fine. Nothing burning yet. And if you're curious why I'm worried about something burning, it happened to me plenty of times, to be honest. I like burnt diodes, I burned IACs, I burned Zenir diodes. I pretty much burned everything. I didn't burn a microcontroller yet, so that's a given. I've got friends that burned the microcontroller, but that's fine. Anyway, I'll do a couple more steps, and I guess the next episode will be the soldering episode and finishing off everything episode. So I'll see you in that one. I'll stop the recording here, I'll unplug everything, and I'll pretty much clean up everything now. See ya.
Okay, it's me again. So at the end of it, you saw that there was actually around 38 volts, 37 volts, and it's an explanation, I guess, for that. Basically, the calculation is right. So the calculation, there is nothing wrong in it. The problem is the ICs that I bought, the amplifiers, They might seem real op amplifiers, but they aren't. Usually, when you want to use op amps or any ICs, you go to the, I guess it's called Texas Instruments or something like that, Texas Institution, and you buy the legit ones, the ones that have been properly made. However, if you go to Amazon and you buy op amps, you can buy also the Chinese version of it, which are the really cheap ones and are the ones that are not the best rated ones. And the reason I bought the really cheap ones, of course, is because they are cheap and because I like to use them. And I just realized now after I did the entire circuit that it might be a bad idea and it might be the cause of why the circuit didn't follow the calculation. Because basically they are of lower quality. Maybe they have internal resistance, the impedance higher than usual. And yeah, but again, beggars can be choosers, so I made do with what I have, and it doesn't really make that much of a difference. It's only a difference of about 2 or 3 volts. And again, everything works properly as well. Alright, so just want to clarify that the ICs that I use are not the good ones, they are the proper ones. And again, to clarify that the next episode will be us putting together the entire circuit on the breadboard, on the board for soldering. And the episode after that will be us making a report about it, because I think report is important as well. Now, um, so yeah, I would count this successful in a way, I guess. I mean, I did get the result that I wanted, but I don't know, it's just not as efficient as the actual product that you buy, and I shouldn't expect it to be as efficient as the actual product. So yeah, it was a nice experiment. Now, as the last step, I will let you with some music, some beats from my friend Nick, and it will just be a speed up of me drawing the circuit in a random program that I found on the internet because I don't own a program for circuit design. So, and this one was quite nice. The only problem with it is it doesn't let you put labels, so I had to download the photo of it, the picture of it, and then put it in Paint, and from Paint to put the labels on it. So that's the only thing. So I'll let you with that for the end of the video, and I'll see you next time. And next episode will be past 8th of January because I'm missing one of the components that I need for soldering, and that will take a while to get here. So yeah, if you are waiting for the next one, it will be past 8th of January at least when the Amazon delivery comes to me. Alright, there you go. Enjoy the last part of the video.